Hello and welcome to the MMO development class, session 11. I'm here and my name is Nelson. So what we're going to be doing today is, like I promised last week, we're going to be taking a look at some of the server code that I'm not super happy with. In particular, if we jump into the Rune Peer, if you guys recall, the Rune Peer has this on-operation request method, which is basically the method that gets invoked every time the client asks the server to do something. Now we've implemented a command pattern to keep everything relatively clean, and I do like the way our commands are looking. So for example, if I jump over to my command handlers, we have some really nice looking classes that allow us to easily separate out the logic for each command in particular. However, I'm not particularly happy with the fact that we implemented it manually. You'll notice what I do here is I deserialize the command and then I manually use an as operator on the object for as many commands that I have, and then I manually invoke those commands handle methods. Now that's not really an appropriate solution for a command pattern. The reason I was doing that was that this code is very easy to understand, it was quick to write, but it's going to be a maintenance nightmare and I don't really like how it's looking. So what we're going to do instead is we are going to use an IOC container in order to register all of our command handlers against, and then pull out our command objects dynamically, and have our IOC container resolve the different constructor parameters that each one of our commands require. So for example, our login handler needs a database session and an iApplication object, whereas a place rune handler doesn't need either of them. So to do that, we need to bring an autofac, configure it, and then use it to resolve our commands. So it should be pretty straightforward. What I'm going to do is I'm going to right-click references, go to manage NuGet packages, and I'm going to search for autofac. And I'm going to install it. Okay. So I just brought in a package called autofac. Basically all autofac does is an IOC container. IOC stands for inversion of control. And IOC is it's sort of a design pattern that allows us to abstract the dependencies of our individual components from the use of those components. See, right now, for example, like I said before, the login handler has a dependency on the database session and the application. But right now we have these dependencies hardwired into our code. A nice benefit of an IOC container is that we can register existing classes with it and then ask for those classes dynamically, which will allow us to, well, write a lot cleaner code. So creating the base container, the base IOC container, I'm going to do that inside of our application class. If you guys recall, our application class is instantiated when our application is launched, and is kind of the single instance of the thing that represents our game, whereas the Rune peers are instantiated for every single connection that comes into the server. So inside of my constructor right here, I'm going to create a autofac container. You do that with, or I'm going to call this container builder. Having some lag here. You do that with the container builder type out of autofac. And what we can do here is we can access, in particular, its register methods. We have like register component, decorator, generic decorator, instance, module, source, types. So that looks like lots of fun. The first thing I'm going to do is I'm going to register things that are going to be available to everything. I'm going to register all the base services. The first service that I want available to every single component that's instantiated with autofac is the application itself. Because we're registering an instance of an object, what I use is I use the register method. The register method takes in a delegate that accepts a iComponent context and returns a thing. Now, I'll go ahead and write that in the form of a lambda, and I'll simply say this. So I'm registering this instance of this object. The next thing you have to do is you have to say, okay, so we're registering this thing, but what are we registering it as? What I'm going to do is I'm going to register it as an I application. That means the only way that our components are going to get access to this object is through the I application interface. The final thing that I'm going to do is I'm going to say single instance. That basically makes a singleton object out of this as far as the containers are concerned. That's appropriate in this case because the application reference will never change. The next thing I'm going to do is I'm going to register my sessions, now my database sessions. Now this is going to get a little bit more complicated. Let me go ahead and find out where I set up in Hibernate. It looks like I set up in Hibernate in my start method, and I think the reason I do that is I want my logging to be started before I set up in Hibernate. So actually I'm going to backtrack right now, and I'm going to take my container builder and I'm going to dump it down in my start method. In fact, I'm going to create a setup IOC method just to remain consistent with us having a setup in Hibernate method. So now that I have the setup IOC method, this will be ran on startup after both logging and in Hibernate have been set up. And that's important because we need to be able to register in Hibernate into our IOC container. Finally, I'm going to move setup IOC down to the bottom because it's a private method, and I kind of like it being in the same order that the method invocations appear. So how do we register a session? Well, if you guys recall, we get a database session out of the Hibernate session factory, which we instantiated in the setup and Hibernate method. So I'm going to register another object, but this time I'm not registering really an object. I'm registering a method invocation. I'm going to say register _ session factory dot open session as iSession instance per lifetime scope. What this will do is every time one of my components asks for an iSession object, this code inside of here will be invoked, which will tell the Hibernate to open up a new session for me. Then I specify that I want to instance one session per lifetime scope. We'll talk about lifetime scopes a little bit later once we get into our command handling logic. But the point here is that because I'm saying instance per lifetime scope, all you need to know about that right now is that the iDispose method, or the iDisposable implementation of iSession, will be invoked properly, and the database connection will be closed by autofac automatically. Now, these are really the only two services I think I use on globally within the project so far. If I jump back into RunePeer and look at my instantiations of my handlers, all I see is that they're asking for either a session or an application or both. So these are the only services I need to actually expose to autofac at this time. We'll be obviously adding more services later. The final thing I need to do is I need to register all of my command handlers. Autofac needs to be aware of each one of my command handlers in order to be able to instantiate them and satisfy their dependencies. So to do that, if I recall, I believe I do register assembly types. So what I'm going to do is I'm going to instruct autofac to scan my entire assembly in order to add things to be resolved from. So I'm going to say register assembly types. I'm going to say, how about type of application dot assembly. That will return the current assembly that the application class is in. Then I'm going to do dot where, which is very similar to the where link method. I'm going to say where type. Then I'm going to say type, let me see, how will I be able to, what I need to right now is a predicate that will match each one of my command handlers. So what I'm going to have to do is I'm going to have to make sure it's a generic type that it's implementing, or make sure that one of the interfaces that it's implementing is a generic type and its generic type definition matches iCommandHandler. The code I'm about to write is very similar in conceptually to my event handling code. Event handling code. Where are you? You're somewhere. I believe you are in, wow, Network Manager, aren't you? No, you're not. You're somewhere. I swear I have an event dispatcher here, somewhere around here, don't I? Is it in Game Manager? Wonderful, I can't even remember where my event dispatcher is. Event handler registration. There we go, it's in my network manager. Remember how we wrote this code right here that looped through all of our interfaces that we implemented? What I'm about to write for the commands is actually very similar. Solution asks, why use type of instead of assembly.get executing assembly? The reason I do that is kind of has to do with how I got used to writing web server code. If for some reason, I can't remember if get executing assembly will return the correct type in the case that another assembly is created and a type that inherits application is dynamically created inside of it. But I avoid using, when doing stuff like this, I avoid using the get type method .assembly, and I avoid using get executing assembly, because those two things can change depending on your executing environment, especially in ASP.NET web projects where your global ASICs is actually inherited from and runs in a different assembly than where you defined it. So I always got used to just doing the type of, then the enclosing type, in this case application, .assembly. It's just there's no ambiguity there, and no matter what weird runtime constraints whatever this is running under imposes on us, it's not going to start failing for any reason. Okay, so then I'm going to do where type dot get interfaces. So this will get or get interfaces. This will return all the interfaces this implements. Dot any. So I want to see. Whoop, I think I imported the wrong dot any. Yeah, I want to do the system link enumerable.any, not the nhibernate util enumerable extensions.any. Why did they add that? It just pollutes the blah, whatever. So I'm going to say if any interfaces are a generic type and their get generic type definition equals type of iCommand handler, then I want to return it and register it. So this code might look a little scary, but all I'm doing is saying, okay, if the type has any interface that is a generic type and its generic type definition equals iCommand handler, then return it. Just like what we did over here where we said we made sure it's a generic type and its generic type definition equals iEvent handler. But here we're doing iCommand handlers. I'm going to go ahead and clean up this code a little bit because we have a few more method invocations to chain on this expression. So I'm going to say register assembly types in the current assembly where they implement iCommand handler. Then I'm going to say as self. Now as self will make it so that those, or wait a sec. Yeah, I want to do as self, I believe. Hold on, let me think. No, as implemented interfaces. Whoops. So I want to register, for example, I want the login handler, this class, to be registered as an iCommand handler of login command. I don't want the login handler to be registered as itself because we don't really know what a login handler is. I want it to be registered as an iCommand handler of login command. So that's why I do as implemented interfaces. Finally, I want to say instance per dependency. Every time I ask Autofac for one of my command handlers, I want Autofac to reinstantiate it and refulfill all of that object's or all of that class's dependencies. Now, so far, that's all we need. We just need our iApplication service and our database session injected into everything. Then we need to register all the things we want to retrieve from Autofac. And now we're ready to be able to actually create the container. So I'll just do underscore container equals container builder dot build. And then I'll go ahead and have ReSharper create a private iContainer underscore container field for me that now contains the instance of the autofact container that's been configured to what we, well, configured it does. So basically handlers are like controllers getting instantiated on every request. Yeah. After the handling is done, they're disposed of. So now ReSharper is telling me, blah, 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 setup IOC does not handle whatever. I'm going to go ahead and add the word IOC to the abbreviation list so that ReSharper will shut up. And then the next thing I got to do is I got to pass my container into my Rune peer. That's because my individual Rune peer objects are going to need to be able to instantiate command handlers. Now I could abstract this into a command handler, resolver class, whatever, but really it's not that needed. The amount of code to instantiate a command handler from a container is minimal. So I'm going to add it as a parameter to the Rune peer's constructor. So I just added that argument, and then I'm going to hit Control Enter to add the parameter. Now I'm going to jump over to Rune peer, and we'll have a nice little container parameter up here in the constructor. Would there be a valid reason to keep any sort of handler instance around? No. Now, there are valid reasons for a command handler to perform additional logic after it's been executed. And we can, unfortunately though, that will result in some difficulties with the way the code's written, and is something we will have to add in manually if we need to. Like return a task or something like that, and we can use like the TPL to do that for us. But in this case, what we're doing is we're just assuming that once a command handler is done, it's done. And we'll see another reason why that has to be that way in a moment here. Okay, so I'm going to alias out my parameter into a local variable. So now I have my iContainer right here. And now I can use my iContainer to replace all of this code. So let's go ahead and do that. I'll leave that code around for a second just so you guys can see the difference. What I need to do now is I need to instantiate a command handler. So to do that, all I got to do is say var handler equals container. Now, this is the container object. What it allows me to do is it allows me to invoke the resolve method. You're going to use the generic type version of this method for a very particular reason. Now, the resolve method takes in a type object, the type that we want to resolve, as well as an optional IEnumerable of parameters, which we won't worry about. So I'm going to say handler equals container.resolve. Now I have to construct a type at runtime to describe what I want to resolve. If you guys recall, I don't register this class as a login handler class. I register this class as an iCommand handler of login command, which means we have to use reflection to construct a iCommand handler of login command type, which is very easy to do. All we got to do is say type of iCommand handler. Notice how I'm using the open type definition of this, so there's no type parameters passed in. Then I do dot make generic type, and then I pass in the type of the command. Whoops. Or actually, I don't have to do dot get type. I can just use command type. And what are you complaining about? Oh, it wants an array. So I'll just wrap this in a handy little array, and it's still complaining. Oh, command type is a string, because that makes sense. Fine. I give up. Command.getType. Nope. Get type. Sorry, there's some lag going on here. Okay, so now we have our handler constructed. Now we can invoke it. And to invoke it, all I gotta do is say handler dot handle. Whoops. Oh, okay. Now this is the next thing. I need to invoke the handle method, passing in the iNetwork session, the command context, and the command. Now the problem with this is that we can't, in a statically typed context, invoke this method because it requires a type that's going to change per command handler. So what we're going to do instead is I'm going to say handler get type get method handle binding flags. I want an instance and a public dot invoke, and then passing in the object, which is handler, and then passing in an array of objects, which are the parameters. Now, the array of objects is going to be, hold on, this code's going to get a little gross here. So what I'm going to do is I'm going to break this out just a little bit. Okay, so we need to pass an array of objects for our parameters. Our array of objects is going to be this, command context, and login command. Whoops, command. I won't be able to compile this code because I need to explicitly declare this as an object array. So this code basically replaces all of this. Now, fortunately, container.resolve will throw an exception if our object is unable to be resolved. What I'm going to do instead is I'm going to use the try-resolve method. So I'm going to say object handler, and then I'm going to say if not container.try-resolve, passing in the service type and the out handler instance. Otherwise, invoke the handler. And then I'll just copy this out. Whoops, it does a return right there, so the else is redundant. And now all of this code goes away. So here's our code to go ahead and invoke our handler appropriately. Now, I'm sure some of you are thinking that unfortunately the speed of reflection isn't very good. And that's true. Right here, this invoke method isn't something that is particularly quick to run. We can use dynamic code compilation to compile the invocation of the handle method, but that requires a little bit extra code, and I don't want to worry about that until we start playing around with other things. Now we're forgetting one more thing before we can go ahead and use this code to run our server. Anybody remember what the last thing that we need to do is? There's one word that I was talking about before in our application where we said we want to open our session per a lifetime scope. Well, we're not instantiating a lifetime scope. AutoFac has no knowledge of when a request comes in and when a request is done. We need to tell AutoFac that this is when a lifetime scope starts and this is when a lifetime scope ends, so that AutoFac knows when to disconnect our session from our database. So what I'm going to do is right now our session is opened from our application. That's no longer going to be true. Furthermore, our transaction, how we're rolling it back and committing it, we might have a command that doesn't actually open a session. And if it doesn't open a session, then, well, we don't want to recreate that session, or recreate a session if we don't need to. However, the first thing I want to go ahead and do is open a lifetime scope. So I'm going to replace var session equals open session with var lifetime scope equals container dot begin lifetime scope. Next, we do have this transaction object here. I'll go ahead and for now, because I honestly can't remember which method I'm looking for. Yeah, I can't remember which method I'm looking for to detect if a session was ever instantiated. So what I'm going to do is I'm going to say, instead of var trans equals session dot begin session, I'm going to say var trans equals lifetime scope dot resolve I session begin transaction. So a session will be opened every command in this case until I figure out, until I remember which of the autofact methods I have to use in order to determine if a session's been opened on this request. Alright, so now we have pretty much genericized our Rune peer code, where our Rune peer no longer has to be updated every single time we add a command handler. So let's go ahead and test this. I'm going to fire up my log doohickey guy, and then I'm going to fire up Photon, which I think I actually added it as a thing right here, and then I'm going to tell it to start. Well, actually, first I'm just going to compile this, then I'll tell Photon to start. Okay, so we've compiled it. Default instance start as application. I'm going to wait for the start to appear, which will take a moment for Photon to get going. Yep, it started. So now, jump back into Unity, hit Control B, and see if our game still plays. And it's taking a second to connect for the first time, unless there was an exception that I don't know about. There very well may have been an exception, but I'm not seeing anything in the logs, so let's try this again. Okay, we're getting nothing. So something is going on. I'm gonna close RuneSlinger, and I'm gonna open it up as an administrator, so that I can attach Visual Studio to Photon, and I can actually do some line-by-line debugging to figure out what exactly is failing. Because I did get this application started, which means that our container was resolved. However, I'm not getting a thing. So let me figure this out. So I restarted Visual Studio as an administrator so that I can attach myself to Photon. But actually, hold on, let me, when a session gets created, what exactly does it do again? It just says peer created at. Yeah, there's no reason why I shouldn't be getting that. Weird. Let's go ahead and add a breakpoint. Actually, I'm going to add a breakpoint a little bit higher up in the create peer method. And then I'm going to go to debug, where are you? Attached process. And I need to make a macro to do this. I did that. I made a macro before and it was very nice, but unfortunately I haven't made a macro yet. So Photon socket server attach. And then I'm going to move Unity up off to another monitor, and I'm going to hit play. And we'll see what happens. Okay, I just realized what I'm doing wrong. Can anybody tell me what I did wrong? The number one issue that you'll run into when you hit play and nothing happens in Unity. Nope, I rebuilt the server. I didn't select my scene. Yeah. Sorry about that. Okay, so let's go ahead and get Unity started up. And hey, look, we have a login. Ah, crap. I forgot to remove that breakpoint. Hold on, let me detach from... Okay, so we're in the lobby now with that guy, so let's go ahead and log in with this guy. And I'm already logged in with A. Then I'll challenge him and hit accept. And 1 goes to 1, 0 goes to 0, eventually. Yeah, I'm getting some awful video lag right now. And then 0 to 0. And hey, look, we won. And then nothing happened. Okay, well, that's good enough for now. We now know that our command handlers are indeed working. So all of these command handlers are being automatically registered. I no longer have to go to the Rune Pier to register each one of them manually. So how's everyone feeling about this code right here? Yay. Yeah, it'd be a bit more pro if I dynamically compiled methods to do this invocation here, but I'm not going to worry about it. A couple nanoseconds isn't going to do much right now. Okay, so the next thing I want to do is I want to go ahead and create a events unit of work. So you'll notice that some of our command handlers do raise events. So for example, our challenge player handler, it goes into the lobby, create challenge. Actually, I think our lobby publishes events, which is going to be slightly problematic. So how about we figure that out after I get my iNetwork session to have better auth. If you guys recall, every time that I need to get my currently logged in user out of the iNetwork session, I have to use the registry. The reason I wrote the registry was to be able to attach components that'll be locked when we access them. But honestly, we don't need a lock for our auth component. So what I'm going to do instead is I'm going to go to components, auth component, and I'm going to rename this to session auth. I'm going to take this out of components, place it into value objects where it should be, and then I'm going to go into network session and I'm going to say session auth, and then I'm going to write an authenticate method that takes in a session auth. Alright, so I've implemented that property and that method. What that's going to do is cause my code not to compile because I need to implement them on my Rune Pier. So I'll go ahead and implement auth right there and then authenticate down here. All authenticate does is says auth equals auth. Simple enough. If I wanted to, I could put more logic there in the future. Now what I need to do is, because the auth is no longer a component, I need to go through every time I use it as a component and fix the code. So let's start with login. When we do log in to our session or to our user account, we say session registry set session auth blah blah blah. Well, instead what I'm going to do is I'm going to say session.authenticate this. And then I'm going to leave the lobby component as a component, and then context.setResponse login response. Random question: would you ever want multiple IOC containers? No, generally never. However, lifetime scopes almost pretty much accomplish everything that you would ever want to do with that. For example, look at the method signature of begin lifetime scope. One of its overloads takes in an action with a container builder, and so if I wanted to, I could do something like this is the stupidest component registration ever, but the point is that I can actually add additional registrations to every lifetime scope I create if I wanted to. But so if you ever need to give your sub components their own registrations, you can do it through this overload. Otherwise, just stick to the root container. But lifetime scopes can be infinitely nested, so there's no reason why this feature in particular can't fix or can't resolve every single problem you might have with AutoFac. But anyway, so in our login handler, we changed our code to say session.authenticate new session auth. We also have to do that in the register handler. Instead of saying session registry set session auth, now I just say session.authenticate session auth. So that code doesn't really change a whole lot, but what I'm going to have to do is every time session auth is used, let's go ahead and say find usages. Didn't I rename that? Because I only found 2 usages. Yeah. Why aren't you find usages? There we go. Okay, so now I have a nice little roadmap of every time I need to replace the registry with the auth property. So now I can say challenge session, instead of saying single s registry get blah 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 blah, all I have to do now is say s auth user or s auth ID. Now I just realized that unfortunately the auth will not work in this in cases where the sessions aren't logged in yet. So I'm going to modify the behavior of this just slightly. I'm going to add a bool is authenticated to my iNetwork session. Actually, no, I'm going to add is authenticated to my session auth. And then when we instantiate a session auth with parameters, I'll set is authenticated to true. When we instantiate a session auth without parameters, I'll set is authenticated to false. And then inside of my rune peer on my constructor, I'll say auth equals new auth. That way we won't have to worry about null references, but we can still detect if they're authenticated. Okay, so that's that usage. Let's go into this usage. All I gotta do here is say s.auth.id equals user ID. There we go. That looks a lot cleaner. Then we have another usage right there, which we've already taken care of. In our lobby component, we have a billion of these, unfortunately. So get session auth equals new lobby session. What I can do here is replace this entire line with that. And then no. We just need that. And then auth ID t auth username. Then we have another usage right here that does the exact same thing. So lobby session is just going to be new lobby session auth ID session auth username. Then we have another usage right here where user ID equals that. So actually we can replace this whole bit with just session.auth.user ID. Then right here is the same thing. Instead of doing that, I can just say session auth ID. Then down here, we do the same thing, where I can just say challenger.auth.id. And then down here, I can do the same thing, where I'm just saying s.auth.id. In Rune Game, I have 2 references. The first one is this one. This is going to be simplified to t.key.auth.id. This is going to be simplified to winner.auth.id. Then in Rune Peer, I have 2 references, which are those. Okay. That should be that. The next thing I got to do is inside of my lobby, I want to prevent people from joining the lobby if they are not authenticated. So in my join, I'm going to say if session auth is authenticated as false, throw new operation or invalid operation exception. Must be authenticated to join the lobby. Alright, I'll go ahead and build, wait for my server to restart, and then I'll do one quick little test just to make sure everything is still in order. And it looks like we can still log in, and we can still chat, and we can still challenge, and it looks like we can still play. Alright, looks good. How religious should we be about getting rid of all those news in the long run and resolving everything from the container? Like, I know we definitely want it for our serializer, for example. I'm not sure where to draw the line. Well, the line is whenever, to me, is whenever it adds value. Typically you want coarse-grained components. So database sessions are obviously a good candidate. Event handlers or command handlers are a good candidate. Application instances are a good candidate. But things like this value object right here, there would be no reason to instantiate it from a container. Generally, your service layer, which I would consider my command handlers to be my service layer in this case, is where you would draw the line with doing that. And then if your service layer ever crosses some sort of boundary, then you would want to inject that boundary into your application. So for example, we cross a boundary right here into Hibernate, which is why the database is injected. If we had, now as far as a serializer, I don't know if I would inject the serializer. It depends on if we want to be able to easily change the implementation of our serializer down the road, which is typically not going to happen much, because the only time the serializer is ever used is going to be in our on operation request method and our publish method. And now both of these are relatively small methods that are self-contained. So I wouldn't worry about injecting the serializer because they're only going to be used in these two instances. Ripping apart all of our serialization logic is very easy because it only appears right here and right here, and that's it. Okay, so there's our awesome code. Now we can add command handlers without having to add additional code to our on-operation request method, which our on-operation request method's getting a little big, to be honest, but it's fine. We don't use it that often, or change it that often. Most importantly, our command handlers are pretty lean. Then we fixed up our authentication and authorization pretty easily by not having it as a component in the registry, but instead having it as a value object that's attached to each of our sessions. So the last thing I'm going to do is, I know I moved a class recently, so I'll go ahead and adjust its namespaces. And it's been almost an hour, so I'm going to go ahead and pause the video, and we will be back shortly. And we're back. Okay, so what I'm going to do now is I'm starting to not like the way that our lobby component is doing its own event publishing and other stuff inside of it. I want the lobby component, because this is a class that's going to be instantiated and available from within the context of the application and not the context of a single request. Doing things like publishing events is going to make it very difficult for me to go about implementing an event handler that's implemented in terms of a unit of work that gets committed after each command gets handled. So what I think I'm going to do is I'm going to move the publishing code out of this and leave lobby component more or less as a object that's responsible for knowing which sessions are in the lobby and which sessions are in the game and so on, and then have my command handlers be more responsible for actually publishing the events. So the first thing I'm going to do is I'm going to create an event publisher. So I'm going to start off with an abstract iEvent publisher, and it's just going to have one method in it called publish iEvent event. Then I'm going to create a concrete implementation of this called event publisher. event publisher implements iEvent publisher, and I'm going to have it, let's see how we can do this, because this needs to be instantiated per each lifetime. It's going to be needed to be available from within our rune peer itself. So for now, what I'm going to do is I'm going to just keep this as a unit of work, basically. So I'm going to have a private read-only list of iEvent called events. I'm going to instantiate that in the constructor. Publish is simply going to say events.add event, and then I'm going to have a public IEnumerable of iEvent called events that simply returns our event collection. Alright, see you, NATO. Okay, then to inject this, all I gotta do is jump into my application where my IOC configuration takes place, and then I'm going to say container builder.register type event publisher as iEvent publisher instance per lifetime scope. I'm going to move actually the events up into the interface. There we go. Then I'm going to go into the iNetwork session, and I'm going to remove the publish method out of that. Then I'm going to go into my rune peer. I'm going to make the publish method private, and because I'm making it private, I'm going to move it down underneath all my protected. Then I'm going to resolve an event publisher up at the top. So I'm going to say var events equals lifetime scope dot resolve iEvent publisher. Then, now within the context of this lifetime scope, events will accumulate. And because events will accumulate, I only want to publish them if we send a successful operation response after the transaction is committed. So I only want to publish my events if we've successfully executed the command. If a failure came in at any point, I just want to ignore these events. So I want to say for each var event in events dot events publish event. So this way events will be published after the operation response, and they'll only be published if the transaction was successful. So that makes them make a lot more sense now. So now I'm going to get a bunch of build errors. Basically, I'm going to get a build error every time the publish method was invoked. Which means at this point we have to move the publish method invocations out of our components and into our event handlers, or our command handlers. So let's go ahead and do that. The one issue I see with this is right here. Our login handler and our register handler both do a lobby.join. We have two options in this case. We can create a lobby service that gets instantiated per transaction that handles this code, and then defers to our lobby component in order to know its current state. So I think I'm going to go ahead and do that. So I'm going to create a services namespace and create a lobby service. Lobby service is going to get a reference to iApplication application. And then we're going to have a variety of methods. One of them is going to be public void. What did I call that method? I called it join, so I'll use the same terminology. So I'll say join. Now what's join going to do? Well, join's first going to lock the registries. So I'm going to say get lobby component. Actually, first I'm going to say if not session.auth is authenticated, then throw new invalid operation exception. Then I'm going to get the lobby component. Then I'm going to say if lobby dot contains session, throw new invalid operation exception. If this works, I'll say lobby.join session. The lobby.join session will change in that it'll no longer perform these checks. It'll simply say sessions.add session. And then I will pull the publish code out into the service. So, to do that, what we need to do is our session.publish is no longer going to be used. Instead, we're going to be using iEventPublisher, and we call this events. And then I'm going to say events.publish. This is going to be problematic, isn't it? Because our events need to know what channel, or not channel, which sessions they're going to be published on. Okay, so that means we're going to have to jump back into my iEventPublisher and publish event. We're also going to have to attach that to an iNetwork session. And it's going to be an IEnumerable of well, yeah, I could do that, or I could do a publish with an iEvent iNetwork session, or I can have a public or void publish iEvent event IEnumerable of iNetwork sessions. I'm not worried about that right now, but we'll be able to implement that easier with this new new publisher. So next we need to know what events we want to publish. To do that, we need to, let's see. What I can do instead of exposing an IEnumerable of events is I can make the iEventPublisher more responsible for the serialization of the events, which will allow us to, in the future, cache each serialized event. So I'm going to make a void commit method. And then inside of our Rune peer, instead of saying for each events and events publish event, I'm going to say events.commit. And then that's that. So now we have to go into our event publisher and alter it slightly, where we're no longer going to need a read-only list of iEvents. Instead, we're going to need a read-only list of tuple of iNetwork session iEvent. And then on publish, I can just say publish add tuple create event session, or session event. And then publish, I can say for each var session in sessions, publish event session. Then on commit, I can do the actual serialization and publishing into the peers themselves. Which is going to mean I'm going to have to cast our iNetwork session into something that I can invoke the send event method on. I could introduce another layer of abstraction, but instead I'm just going to keep this relatively simple. So the publish event is no longer used right here, so instead I'm going to remove this code out of the Rune peer, place it in the event publisher, and then I'll say var peer equals, or so for each var event in events, then I'm going to say event dot or peer base event dot item one dot send event, and then the last thing is the serialized bison method, which unfortunately our serialized bison method is just locked in here to our Rune peer. What I can do instead is I can go ahead and abstract that into an iSerializer and then just have my deserialize and serializer inside of that and have it injected, so I don't have to repeat this code right here. Now, repeating this code isn't terrible because it's very small. The reason I don't want to repeat it is I want to be able to change the serializer easy down the road. Previously, because the serialized bison method was only used inside of the rune pier, I was fine with it being just there. It didn't bother me at all that it wasn't abstracted to in any degree. But because now we need to be able to serialize things from multiple places, instead of copying and pasting this code, it'd be better to put it in a class. And if we're going to put it in a class, we might as well wrap it in an interface and inject it, in this case. So I'm going to Google the spelling of serializer. Got it. And then I'm going to create a iSerializer, or just iSerializer. iSerializer will have a object or a byte let me Google serialize. I'm bad at this game. Serialize, then pass in an object, and then an object deserialize that takes in a byte array, bytes, and a type. I'm not going to do the genericized version of deserialize because, deserialize is one word, because when we deserialize things, we're actually using types at runtime, not at compile time, so the generics would break. So then I'm going to create a class called Bison Serializer, so I'll go ahead and copy the spelling of serializer again. And Bison Serializer will be just a matter of taking all the code we have in RunePier and putting it somewhere else. So we'll instantiate a JSON serializer and create a field, make it read-only because we can. Remove the JSON serializer out of my RunePier, which will give us a nice roadmap of the code we need to replace. This is one of them, our deserialize method. So Bison Serializer will implement iSerializer. No, iSerializer, this one. And the deserialize will return JSON serializer deserialize Bison reader, passing in a memory stream. So I'll go ahead and say var ms equals new memory stream, which is just wrapping our bytes. And then the type will just be type. Then we need our serialize method, which if I go back into my RunePier, we have right here. So I'm just going to literally cut that, delete the method, go back to this, paste it here, and change object to obj to object. So now we have a Bison serializer. So what I'm going to do now is on my RunePier, when I construct my RunePier, I'm going to say serializer. Because this is going to be a singleton, I'm just going to instantiate it once, or resolve it once in here. Container.resolve iSerializer. And I don't like the fact that I'm instantiating two properties. Okay, that looks better. And then, now I have to replace all these, so serialize Bison, I'm just going to say serializer.serialize, passing in the object. Serializer.serialize, serialize.serialize. So right here, we have using var ms equals new memory stream, JSON serializer.deserialize, which will just be serializer.deserialize. Passing in, we no longer need to create the memory stream because that's being handled from within. The type declaration becomes redundant. We no longer need to pass in a new Bison reader. Instead, we just need to pass in command bytes. And there we go. We have now abstracted out our serializer into something that we can reuse elsewhere. So what I can do now is jump into my event publisher and have my event publisher accept an iSerializer. which I can use right here to do that. So here's our event publisher. The only thing I don't like about this is how we're assuming that an iNetwork session is an implementation of pure base. I don't like that, but I think it's the amount of code that I have to write to make this more pure is not worth the benefit of having this one line of code not be ugly, in my opinion anyway. And we'll, we can always readdress it later, which is what I've been doing. I've been just readdressing things one at a time as they come up. Sometimes problems like this, something like this is a red flag to me. But sometimes red flags, they'll turn out to be a real problem down the line. Sometimes they won't. I just don't want to waste more time working on that because it's not very important to me. The last thing I got to do is inject my Bison serializer into my container. So I just say container builder register type Bison serializer as iSerializer, and then it's going to be a singleton. Okay, so now the only code I have left to write is pretty much everything that throws an error. We have 14 errors, and those are all due to the publish method. So let's start off back in our lobby service. Instead of session.publish, it's going to be events.publish, and then I'm going to pass in a session. Instead of sessions.select, I'm going to say lobby.sessions.select, which I'm going to implement as an IEnumerable of iNetwork session. Sessions is simply going to return our hash set as an IEnumerable. So now our lobby service becomes this. Next up we have a thing that we do that. We can actually fix this code to where I can just say publish new session join lobby event, lobby session, and then I can pass in an IEnumerable of iNetwork sessions, which is very easy to do. I just do lobby.sessions. Now, this is a small problem. Well, is it? Potentially, yes, this is a problem. Can anybody see a potential race condition that has been introduced by this code? Anyone? Well, I'm passing in a reference to an IEnumerable into my events.publish method. The events.publish method is only going to access this IEnumerable when the events are committed. The events will be committed after this block is closed. When this block gets closed, my lock is no longer established on lobby component, which means potentially our lobby.sessions might change between the time that it takes to actually publish this particular event. And actually the same is true for my join lobby event now. Because my lobby event, I pass in an IEnumerable, I do a select, but I don't flatten out the list. So that's what I'm going to do. I'm going to put a .toList here, and I'm going to put a .toList here. Well, actually, hold on. Maybe that isn't true in this case. No, it gets enumerated right here, fortunately. For some reason okay, never mind. So this wouldn't be a race condition, but this one would have been a race condition, because this enumerable would have only been enumerated when the event was actually serialized. It doesn't get enumerated until the event gets serialized, unless I add a toList. And remember, the events are now being serialized after my command executes, instead of during. So we now have to keep in mind that we don't want anything outside of this lambda to access the lobby component. That's why I wrote the registry in the first place, is for a basic pessimistic locking scheme where I lock the lobby component, because the collections I'm using inside of lobby component are not thread safe. So I need to lock it every time I access it. Anyway, so there's my join method for my lobby service. So that's pretty. What I'm going to do now is I'm going to inject my lobby service into my container. So I'm going to go into application. I'm going to say container builder register type. I am not going to worry about abstracting this into an interface, because I don't see any reason to. So I'm just doing as self. There's no the implementation of lobby service is not going to change. And if it does change, then it is a different component, and it should be, yeah, basically no reason to do that. This is something that some people just hate injecting in classes like this, but never had a problem with it. Unless I needed to stub out the lobby service. But if I needed to stub out the lobby service, I wouldn't stub out the lobby service, I would stub out the I application and the I event publisher, and let the lobby service do its own thing. So, stuff and things. So now I have a join method on my lobby service, and it is in the container. Because it's in the container, my command handlers can now access it. So I'll go into my login command, and I'll add a lobby service parameter to it. Because I added this constructor parameter, Autofac will automatically fulfill it, which means I can jump down here. Instead of doing application registry get lobby component lobby join, I can do lobby.join session. So that's nice. Now the only reason I created the lobby service instead of having the publishes right inside of my login handler was because I do this twice. I do it here in the login, but I also do it in the register. So instead of doing this, I'm going to do lobby join session. Fairly simple. Now, I have the login handler done and the register handler done. So let's do the next thing that we would have to fix. That is the send lobby message. What this does is says registry get lobby send message. Instead of doing the lobby, accessing the lobby component directly, I'm going to say lobby service lobby, and I'm going to say lobby.send message session command dot message. The next thing I'm going to do, I'm really quickly going to go ahead and clean up my event handlers real fast. I no longer need a reference to iApplication. And I also, in my register handler, I don't need an iApplication. And in my login, looks like I still do need an iApplication. Yes, I do. So I'll keep it in the login. I'll just clean them up as I go down the list of things to fix. Okay, so we have the lobby send message. That means we have to jump into my lobby component and jump into the send message method and paste it here. So instead of doing underscore, the first thing I'm going to do is I'm going to establish a lock on the lobby. So you can think of the lobby component as my kind of model or entity, my persistence mechanism, and then you can think of the lobby service as the business logic for that persistence mechanism. And then you can think of the command handlers as the glue between the client and the business logic, if that makes sense. Does that make sense to everyone? And nobody responds. It smells like purple. Well, which part of it is getting confusing? In lobby sessions, publish event and existing session. Okay, so there's my send lobby message. What else do I need? Now that I've done login, register, and send lobby message, I'll do challenge. So challenging just does this. We say lobby create challenge, blah, blah, blah. So I'm going to do the same thing where I will move it. Actually, we don't need a database or an application. So I'm going to delete both database and application, and then I'm going to create a lobby service, lobby dot challenge player. Actually, we do need an application. and then challenge player session, challenged session, and then I'll cut that, paste that down here, and then I'll get rid of these. You like this? What do you like? You're writing conflicting messages. Oh. Yeah, well, I had to put it back because, again, the responsibility of the command handlers is to translate the will of the client into an invocation of business logic. And part of the will of the client right here is to identify the player that we're challenging by his user ID. So what I want the command handlers to do is I want them to take the commands they receive from the client and turn things like IDs into actual objects so that inside of my actual business logic, I don't have to worry about doing that conversion. So like I said, I have 3 layers right here. I have this, which is responsible for taking the will of the client and translating it into object-oriented code. Then I have this, which is responsible for doing the business logic of the code. Then I have this, which is responsible for containing data that is consistent in that it's pessimistically locked. So again, I just have 3 layers. And the reason I need the application right here is because I need to translate the user ID into a session. So there's not much else I could do there. I don't want the business logic to have to worry about things like IDs and stuff like that. They should get fully hydrated objects when they work on their stuff because then the code's a lot cleaner and the separations are more clear. Okay, so what I'm going to do is I'm going to have this method return a Boolean, and then I'm going to take this context thing and I'm going to say if not context raise operation error. I don't want the context, I consider it to be sort of the view, I guess you could say, if you thought of this in MVC in terms of ASP.NET MVC or some other similar web framework, where the context is sort of going to be what's sent back to the client. I don't want the lobby service to really care about that, other than the events it publishes. So we'll say lobby.createChallenge. What does this do? Well, create challenge, it does some validation and it publishes something. So basically what I'm going to do is I'm going to leave the validation in there for now, and then I'm going to take the publishing and I'm going to move it out into this. I'll say if not lobby create challenge return, otherwise we want to say challenge session publish. We'll do events and then we'll publish that to the challenge session, passing in session.auth.id. And then I'll say var equals false, equals true, return OK. So there's our challenge player handler. It's now being moved around properly. I can delete the send message, by the way. Okay, next up, we have to do our respond to challenge. So our respond to challenge will be very similar. Actually, what we can do is we can just say challenge.respond right here. And then challenge. Actually, hold on. Challenge components do have publishing in them, which means I'll have to move that out into either A service layer, or B, the command handlers. Because the challenge is so simple, I'm going to move it into the handlers themselves. So this handler will have an iEvent publisher events, and we'll go ahead and say basically move all of this business logic from this into that. Direction becomes command, or actually our challenge component is set on both of our sessions. Let's think about how we can do this in a way that makes sense. So we have our respond to, which think here. See, I'm not really liking the way the challenge code ended up being. I think what I'm going to do is I am going to go ahead and create a challenge service. The reason I'm going to do that is because I want to be able to actually go ahead and abort or accept or reject a challenge from multiple places within my code. Because I'm doing that, I need to have it put somewhere that gets dependency injected and stuff and things. Okay, so let's think here. When our lobby creates a challenge, we set a new challenge component on both of our sessions, which is good because now we like I said before, we're considering our components to be kind of the state that our current sessions are in, which means that in our challenge service, what I'm going to have to do is I'm going to have to say public void respond. The respond will take in a challenge or an iNetwork session. Responder, and then it'll also take in a challenge response, and then it'll figure out what to do from there. Now, because this guy will be doing events, we'll have a iEvent publisher events. So now we have a respond to challenge handler, which says register get challenge component challenge respond. We're not exactly doing that anymore. Instead, we're saying we don't need any of that anymore. I am actually liking this a lot more for a couple of reasons, primarily because our challenging is now centralized into a service that will be able to have access to both the database and the event publisher. Now, we don't need the database right now, but we may in the future if we want to track challenges. So, yep, it feels very familiar to me now, just like controller services at work. Yeah, that's basically what I'm doing. I'm considering the components are no longer a combination of persistence and service logic. Right now, the components are just persistence and nothing more. A way to attach a object-oriented flag, I guess you could say, to a component or to an object. Whereas the service layer is actually now performing the business logic, which is good. Okay, so I'm going to go ahead and take all of this respond out, and I'm going to do this. Now, I'm going to have to actually do this from within the lock. So I'll do that, and then I'll do if challenge.direction equals that, then throw, yeah, you cannot respond to a challenge you created, good. And then I'll say challenge.othersession.publish challenge responded to. Instead, this is going to be events.publish. That. And that's not how you spell response. Sorry about that. And then I'll say if response equals challenge response.rejected, then we destroy it. What happens when we destroy it again? If we destroy, we just remove the two components from each other. So what I'm going to do is I'm going to say challenge.destroy. If it equals accepted, then we have to accept the challenge, which I'm going to place inside of the lobby service. Or actually, I'll figure that out in a moment here, after I go through my challenge component. Now, abort says destroy in other session.publish. Now, this is no longer going to be the case what I'm going to do is I'm going to take the abort method, take the respond, remove it, take the abort method and place it within the challenge service. And the abort is going to take in an iNetwork session, which is going to do session registry get challenge component. Which is going to say challenge.destroy, challenge.othersession.publish, which is just going to be challenge responded to with the responsive aborted. There we go. So that's how we abort a challenge. Yeah. Well, I mean, they are the status codes are pretty well established and well understood. So, you know. Okay, so our challenge component now has this stuff. We no longer need a reference to the iApplication from within the challenge component, which is good because all the challenge component does is it's a thing that contains data. It's just a dumb value object. It doesn't really do much, which is exactly what we want it to do. So then we do that. Actually, what I'm going to do is I'm going to move this code into my lobby service where it should be. So lobby service.challenge player will do this. Challenge session is the challenger. So that means that. And then the challenged is going to be the challenge session. And then this is going to be a challenge direction of challenged. This is going to be challenge session, and then session. Why does our challenge component need a session? Oh yeah, because we set it to the property. That's fine. Actually, no. I want to remove the reference to its own session. That's unnecessary. Which means our challenge component gets... Oh, we do need a reference to it to be able to destroy it. Derp. Okay, and then what I'm going to do is back in my lobby, I'm going to fix this up a little bit to just be that. And then I'm going to rename this to try create challenge. Because it doesn't really actually create a challenge. All it does is validates that it can, or how about can create challenge, or is challenge valid. There we go. That's a lot nicer and a lot more in line with what I wanted this class to be like. So now we have our challenge player, which happens right here. That's all good. If we jump over into, what else do we need? So our challenge component is done, challenge player is done. The last thing, how many errors do we have left? 7 errors. Application doesn't exist in the context. Yep, I'll work on that in a moment. We need the leave method implemented. I'll implement that in a moment. And then we need to change the accept challenge method. Okay, because the accept challenge method happens in our challenge component, or sorry, our challenge service. It happens right here if we accept it. Because if we accept it, a lot of stuff has to happen. We have to instantiate the game and get all that stuff done. So what I'm going to do is I'm going to, first of all, I'm going to tell the lobby, I'm going to say, I think you'll be paying for starting late today. Yeah, I just want to wrap this up real fast, because this is, the architecture actually now is getting more and more defined as we're going along, which was pretty much what I wanted to happen. So, what do I need to do? Okay, I'm going to have the challenge service be responsible for instantiating the game. That makes the most sense. The lobby, all the lobby needs to know is if a session is in a game. But we can know if a session's in a game not with this hash set, we don't actually need this hash set. All we need to know is if it has the game component attached to it. Which means I can delete sessions in game entirely, delete the leave game method because that's no longer going to be used. The leave method I still have to figure out. Is challenge valid will no longer check to see this. Instead, they will say if not challenger registry has game component. Wait a sec, what do I call this? Rune game. Of course I call it rune game. That makes total sense. And then I'm going to say, or if challenged has rune game. That way we can know if it's in a game without having to tell the lobby explicitly that we've joined a game. Now the accept challenge method, I'm going to take everything out of it and I'm going to move it up to the challenge service where it should have been. We no longer need to say sessions in game. And we can delete this last line of code. Now for underscore sessions, what is underscore sessions? For each. So we say sessions in new game, sessions joined event, for each sessions and sessions. Now what we can do instead is I can go ahead and say events, publish, sessions, joined event, and then pass in all of the sessions in the lobby. Which means I have to get a lock on the lobby too. So what I'm going to do is I'm just going to say create game with challenge. Because this method is going to get a lot longer than what is appropriate for right there. So on create game, I'm going to have to lock the lobby so I can access our all the sessions in the lobby. So I'll ask for an application. I will say application registry get lobby component, lobby. So we've now locked the lobby, which means I can now publish to every single session that these sessions are now in the game by doing that. Then I can remove that for each statement. I can instantiate the game, destroy the challenge, and then for each session in sessions in new game, session registry set game. And now they're in a game. Okay, lobby component. We still have this leave method, which is going to be problematic, but actually, no, I know how to fix that. So before we finish up with the place rune, let me see, we need to finish up with the place rune and the rune game. These are the two things we need to fix. So what I'm going to do is I'm going to, first of all, I'm going to fix the lobby component entirely. Now the leave, what I'm going to do is I'm going to create a command handler for leave. But it's going to have a command that's internal to the server. And the command is going to be disconnect command. Then I'm going to create a disconnect handler, which implements command handler of type disconnect command. And now I can handle that within a command, which is much nicer. Which means I can now say ask for the application, and I can say application registry get lobby component. Then I can say if lobby contains session, then lobby leave session. And then I can do all of this code within here, which means I need to pull in my iEvent publisher events, and I can say events.publish new session left lobby event, and then I'll pass in lobby.sessions, which I'm actually going to, hold on, I'm going to reverse that. And then I no longer need that code. Then I say session try get challenge challenge component. If we have a challenge component, then I want to dispose of it. So I want to create I need a challenge service. So that I can say abort, passing in the session. Okay, well that's a lot nicer in a command. A lot nicer, actually. Happy with that. So what I'm going to do now is I'm going to go into my Rune peer, and when we disconnect and say application.destroy peer, application.destroy peer does this, which isn't what I want. Instead, what I want to do is invoke that command on the peer. So I'll actually invoke that command on the peer when we're in itself. And then I'll say container, or first of all, I'll say using var lifetime equals container begin lifetime scope lifetime.resolve iEvent handler, no, I command handler of type disconnect command dot handle this empty command context, and the disconnect command is just empty. So now we have a disconnect command that has all of our infrastructure injected into it, which is nice. So now that pretty much completes our lobby component, and this is what our lobby component now looks like. We no longer even need a reference to the application, which means that's actually going to break some code. There we go. So lobby component no longer needs it. It's just a way to persist data and do some basic validation. That's really it. So that's honestly pretty straightforward. I'm liking how that's looking. The last bit that we need to fix up is in the challenge service and the Rune game. This create game should really happen at a service level. So what I'm going to do, I'm going to create a Rune game service, which will take an iEvent publisher events, and it'll have a public void create game. Create game will basically take in the parameters that this game gets, which is nothing. Well, an IEnumerable of sessions, of course. And then what I'm going to do is I'm going to do all of this logic from within the game service. And I'm going to do that outside of the lock of lobby. So we're just crossing that boundary right there. You could use a command pattern to do communication between services, but I'm not going to. Sessions in new game is going to be instantiated outside of the Lambda so that we can access it right here. And then we can keep all the logic for creating the game inside the Rune game service, which is going to, we'll destroy the challenge outside of that. So we don't need to destroy the challenge there. We can instantiate the new game. We can loop through all the games and do that. Now, inside of our Rune Games constructor, we have this initialize method. And this initialize method has these invocations to publish to all, which is going to be slightly problematic. So I'm going to need a way to be able to access that from outside of the Rune game in order to notify everybody that they have been joined into a game. So let's see here. Let's remove that to give us a nice roadmap of what we need to fix. I'll ignore place rune for now. Our biggest concern is initialize. We need to pass in the game parameters, we need to pass in the rune slots and the runes, and we need to pass in the game started event. But I want the actual instantiation of all of this to happen within the game itself. So what I'm going to do is I'm going to create a couple properties. I'm going to say public board width, board height, public IEnumerable of server runes, public IEnumerable of server slots. Whoops. Come on. Okay, and then I'll go ahead and set board width and board height right here. Pass it into here. I'll put those into constructor parameters eventually. And then publish to all. This is going to happen within my Rune game service, which means I also need to expose which sessions are in the game. So public IEnumerable iNetwork sessions get return sessions, and there we go. So let's move this one out first. So publish to all is actually just going to be events.publish, new game parameters established event, game.board width, game.board height, which this wants uints. Basic what? What do you complain? Oh, I never passed in the things. Game.sessions. Then after we do that, we need to do these three published alls. And then we need to fix those references to board width and board height. And then I can go ahead and change these to that. I can change this to game.slots, game.runes, and then I pass it to game.sessions. Okay, so the last bit that we have to do is we have to figure out our other session in the case of placing a rune, and then our publish to all when the game is over. Now, the game being over, I'm going to go ahead and comment this out for now because we haven't even worked on the challenge or the game being over's display page for the result of the game. So, because we haven't done that, I'll comment that out. And then I'm going to keep this as a public bool place rune, and inside my Rune game service, I'll have a public void place rune method that takes in an iNetwork session uint rune ID session.registry get Rune game if game dot place rune session rune ID uint slot ID. Then what do? We do something. Oh, we just return false. But if we succeed, then I want to say events.publish new rune placed event, and then I want to pass in game.sessions.where t does not equal session, because we don't need to. Wait a sec. Rune placed event. Okay, so we do that, and then we need to. Wait a sec. I copied and pasted that code twice. There we go. So there's our place rune event. If we go into our place rune handler, we have a response that we handle back. We don't hand events back in this case, so that's good. So then the place rune handler will simply receive a rune game service, which instead of doing that, we can just say was place equals rune game service dot place rune session command rune ID command slot ID, and then we can inline that, and then we can make the place rune method actually return a boolean, because currently it doesn't. And we get a successful build. So let's make sure that I injected everything appropriately. If I jump into the application, we need challenge service and game service, and that's build. And nothing happens. Let's see if this is blah blah blah. If this is just a quick thing. Join lobby event. Actually, no, it just says sending, which happens if the state is never updated. But the state is always updated if we get a response from the command, which means we could potentially not be getting a response from the command. Let me try that one more time. Okay, it just says sending. So if I jump into my command handler for login, we still set the response to login response, and if I jump into my rune peer, if response is not equal null, then serializer serialize command, context command, blah 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 blah. Okay, let's go ahead and make sure that the command is actually being sent appropriately from server. So I'm going to go ahead and attach myself to debug attached process. Where are you? Photon starts with a P, doesn't it? Why is everything backwards? There we go. And then I'm going to move this up, and I'm going to hit play, and I'm going to see what happens when I send in a command. Okay, so command comes in. It does get deserialized properly. Our response does get set to, I guess that's right. Now our events, there are no events to commit. Okay, so the response does get set. But the event does not get sent. State. Oh, right. Yeah, we never actually... In the case that it is valid, we're expecting that event. So let's see why our event isn't getting fired. The first thing I'm going to try to do is make sure that our event publisher is instance per lifetime scope. That's good. Then if I go into Rune Peer, we create our event publisher right here after we've created lifetime scope, and we do create it from the lifetime scope. Oh. There's the problem. I did container.try_resolve. I was resolving it, the command from the container, not from the lifetime scope. So it was getting a different instance of the event publisher. Alright, so now we're getting a exception. Could not load system tuple iNetwork session. What? Wait, hold on, what am I publishing? Oh, I'm not publishing the event, I'm publishing the tuple of iNetwork session and event. That's not good. Event publisher, event bytes equals serialize event.item2. And the type is event.item2.getType. Okay, I'm just exporting a build out real fast so we can see if we can get some network action going here. And we get chat. And we get challenges. And we get a game. And we don't get notified that the game was won, but that's fine because I commented that code out. The only thing we're getting now is we're getting a element with the same key already exists in the dictionary on add session. Who calls add session? Add session is called by the lobby go. Session join lobby event. And it's also called by that handle join lobby event. I must add it twice somewhere, somehow, for some reason. Let me look at that. It should be easy. With the way the architecture is now, it should be very easy to track down code. I mean, even it was before because there was so little of it. But now what I can do is I can go to the login handler. I can go into lobby.join, hit F12, and then here's all the code. So we say lobby.join, but we know the lobby doesn't fire any events. Our event is published right there. Ah, well that's, yeah. There we go. That should get rid of that exception. And also note that our other sessions that were disconnected are not displayed. That means that our internal disconnect command is being fired, which I really like the way that code turned out, where all we have to do is, in the Rune Peer, all we have to do is instantiate a lifetime, resolve the command handler, and dispatch it. And then that way we can leave all of our actual logic for what happens when a client disconnects inside this class. So yeah, I'm fairly happy with how things are going. But I think that's going to be just about it for tonight. Next week, I have no idea. My brain is dead. Next week, we'll probably maybe be spending the first hour cleaning some more stuff up and then spending the next hour getting into CGS. Or spending 2 hours cleaning stuff up if I can think of anything over the next week to figure out what to do. But right now, my brain is dead. So I can't think. So to all you future people, I will see you guys later.